Good morning, everyone. So, Leonardo da Vinci once said that wisdom is the daughter of experience. Heartily greetings to all the curious minds present here. My name is Anirudh Chaturvedi, and I'll be your host for today's event. Vimrishyotsava has been rising up on the graph in terms of providing wisdom, knowledge, and entertainment to the students all through its previous season. Episode 1 of Vimrishyotsava 2.0, an erudite festival of discussion with our alumna, Ms. Ruchika Prasad, received great love from the students. Anuvrat, the Departmental Club of Electronics and Communication Engineering, is delighted to present the second episode of Vimrishyotsava 2.0. Now, let's hold all our thoughts on this opportunity and with great curiosity, welcome today's alumnus, Mr. Animesh Raj. Sir has completed his high school education from Delhi Public School, Bokaro. He then completed his bachelor's in Electronics and Communication Engineering from the National Institute of Technology, Sikkim, in the year 2017. He has also pursued a master's degree in Optoelectronics and Optical Communication from Indian Institute of Technology, Delhi. He has done a 3-month internship in research and development of wireless modem at Qualcomm in the year 2019, and is currently working as a hardware engineer in the same company since July 2020. Without any further ado, please join me in welcoming Mr. Animesh Raj, and let's hear him share his knowledge and experience on the topic of VLSI design with us. Sir, now the platform is all yours.
Hey, thanks a lot, Anirudh. So yeah, we'll start it, and but 1 second, let me share my screen first. Um, I think I have an issue. 1 second. Um, is it visible, guys? Anyone?
Yes.
Okay,
Yes, sir, your
thanks,
screen is visible.
thanks. Yeah, so I'll say a few things first. So I've tried to keep things pretty simple so that everyone can go inside. I will not go into the deep topics, right? I'll just keep it very straightforward and simple. And I hope all of you try and understand this, because I think this is a very good topic for the EC guys, as they will be going for their uh, options and in future after college. So I think this is a very good industry to be on. So let's start. So first of all, I want you to know why power, right? Why are we so keen to understand and study this? And with that, I'll ask you a simple question: is that what common do you see in all of these pictures? Anyone, if you can just identify what is the common element in all of these pictures shown?
They all require power to operate.
Uh, yeah, I mean, any device would require power to operate by that answer, but that's a very good answer. But any more detail can you add? That's partially correct, but yeah.
Semiconductor and chip.
Yeah, correct. There are semiconductor chips. They need semiconductor chips. Uh, good answer. But I'm looking in terms of power, something with power to do.
They require low voltage power.
Low voltage power. What do you mean they require low voltage and low power? That means that's uh, uh, I mean that's good. That's a good answer. So yeah, you're fairly correct in that sense. But the one thing that I wanted to uh, you know imbibe in use that these all are handheld. These are not plugged in, right? These all will be having a battery basically. So the power is very much important when it comes to handheld, you know, devices like phones or laptops or earphones, pacemakers, watches, and any device. And nowadays, I mean, you can see right everywhere, every device around you is a handheld, is not a plugged-in device, right? So the first thing, that's why we need to study this, because any industry you go, everyone wants less or low power, low power designs. Because of why? Because we have an increasing demand of these type of things, right? We tend to have, I mean, we are going for, all sorts of devices which are having no wired things, right? So that's why we need to discuss this. And also the battery will have its own negative things, right? Battery will add weight. Battery size is large, right? So any phone or any electronic items will avoid having large amount of battery packs, right? So second thing I want to discuss here is the cost. The moment you have high power dissipation, you need to add certain packaging that will counter that. Cooling, devices or cooling packaging. So every time you have a high powered device, or you don't have the control on the power, it adds to the cost. So if you're selling something for X, it'll go 1.3x, 1.2x. So that's why the main motivation is, that's why we are studying this power, right? And the third point to this is that you see the wireless communication systems nowadays, they need high speed communications, right? So for high speed, you need to have a high clock, and high clock simply translates to more and more power, right? Also for non-battery operated, like workstations, server farms, you see, even there as well, if you try and come up with a design that has very low power in it, it will drastically reduce the cost. Because if in those kind of systems we have a lot of cooling systems, a lot of heat sinks there, just to ensure that this does not go out of the way, right? And the fifth point, obviously, you don't want to burn power unnecessarily, right? If we can do some things in a very low power, why to waste power, right? So these are the basic points that are very necessary for as a engineers to understand why power is so important, right? So with this, the next slide, and I just want you to understand this flow before we go into the actual power things. I mean, was explained by one of my juniors as well here, but okay, it's fine. We can explain it, again. So here, I mean, this is a flow. So we'll see is that at every stage, right? We'll see how power is controlled, or how power is monitored at every stage. So you don't want to have a system like that. If you don't want to have a things that you make some things and you go to up till chip packaging and fabrication, and then you decide, okay, it's having a high power, so let's just cut it down. That doesn't happen now. So you need to be aware of power dissipations along the route. You need to be aware from the specifications itself, at functional design, at circuit design, at PD, at every stage. You need to be aware what amount of power we are burning, because we cannot just go back, and we can just do some things and go back and come back and again start from scratch. That will take a lot of time, right? Unnecessary time, unnecessary uh, failures will be there. So we don't want to do that, right? We won't go in much details of this flow, but we'll see some parts of it and how it affects our power planning. So first we'll look at the power dissipation of a CMOS inverter. It's a very basic circuit. You must, I mean, all of VC students must know this. And so we'll go with three kinds of there are three kinds of power dissipations here. First is static power, which is basically leakage, right? And leakage will happen. You cannot stop leakage, right? Leakage is a device characteristic that will always happen. If you want to stop it, we need to go at the device level, at the even at the transistor level. We need to design it very efficiently, but leakage will be there. You cannot stop much of that, and that's basically due to some. I know every transistor is a diode, right? It's a two diode thing. So it's a forward based diode at the front end, and the back's it's a reverse bias diode. And diodes have those currents, right? Reverse currents where you don't want to burn power, but it burns, right? So static power will always have. Some leakage your CMOS circuit will always have. And the second reason is the sub-threshold current, where you don't have, and when the PMOS or the NMOS is not on actually, but still it consumes some little bit of current, right? And so this is the first thing, leakage power. Dynamic power, if you come, dynamic power, you can see these blue lines here. So dynamic power is the switching power. So if you switch on it, so the VDD comes, the voltage comes from this VDD to this V out, and it charges this C. And again, if it's discharges in the second cycle, right? So it's switching. And this is the main reason for the power consumption in our circuits. So I almost around 90% or 85% of all of the power that you see comes with this, right? And around some 5 to 7% from static, and some 5 to 7% from this short circuit power. So you need to be very keen and very um, observant on this as you go ahead in the flow, and you must be very um, uh, you know, s- mm, attentive to see that the dynamic part should not go up, right? And there are very techniques, a lot of techniques to control this, and we will see some of them in a while. And the third is the short circuit power. This is basically when your PMOS and NMOS both are on. So when the output goes from 1 to 0 or back, there is a point where you have NMOS and PMOS both on, right? And that's a dotted line here, the red dotted line here. That is a path of short circuit power. So it comes VDD straight to ground, right? It does not charges C. So you need to understand there's a difference, right? It's straight goes. It's not having any functional activity here. Only thing that is happening, it's just wasting our power, right? Wasting our uh, voltage. So we need to avoid this. We need to avoid this. Dynamic power we can't avoid. We need to have efficient you know design for this, so that we can minimize this as less as possible. We can have a very less dynamic power, but large designs, it will have some good amount of dynamic power. So, and this dynamic power is given by CL VDD square, and F01, which is given by the activity factor into F clock. And we'll see this in some of the slides as well, how to control this, how to monitor this dynamic power. But at this stage, I want you to understand is that the static is around 5%, dynamic is 90, and short circuit is 5 to 7%. So these are the main power dissipations in any CMOS circuit. But I want to ask a question here: is that static power or the leakage power is 5% of the total power consumption? But why it is important? Why can't we just leave it like that? Why can't we? Why you are so worried on leakage as well? If you have 5%, it's a very less margin, right? We can simply say it's fine. We can burn that amount of power. We save on dynamic. Why to worry on leakage? Anyone? Okay, let's keep this question for a while, and if anyone wants to answer, you can answer. So yeah, now we'll look at the. So these are the basic power dissipation, theories and all. Now we'll look what are the design techniques we have implanted, we have used in our VLSI in the industry to reduce or control these kind of power dissipations. So first we look at the leakage things. So you see, the leakage comes from the drain to body, drain to gate, gate to body. Everywhere will have some amount of leakage, and these all join in, and this comes around 5%. And so this leakage uh, can be, there are some methods to control that. First thing is that dual Bth partitioning. So we have two kinds of cells basically in our designs: the low VTH cells and the high VTH cells. Low VTH cells are faster but are more leaky, and high VTH cells are less leaky but are slower. So there's a trade-off here. If you are meeting the timing and you have sufficient amount of space, use some low some high VT cells, right? Because they are less leaky, but you cannot use some larger amount of high VTH cells. That will slow down your design, right? And we can't afford that. So this is the first thing. And also we need to keep an eye on the critical paths, right? Because we cannot lose on functional issues, right? We cannot lose on logic activities. For example, is suppose a half adder is there, it has to function as a half adder. If you cannot control the timing, if you have a violation in the timing paths, this will not function at all, right? So you need to see its functional stability does not get uh, uh, disturbed, right? You need to have functional stability. With that, you need to have some amount of reduction in the leakage. And the second technique that we use is power gating. So power gating is pretty simple. If the picture, so power gating is very pretty simple. It's just like that you use some sleep PMOS device and an NMOS device here, and simply just cut off. So you turn off the supply rails using some transistors when you do not want to run it, right? Suppose you are working on some other block, and the other blocks are waiting, right? So you can just power gate that. Why to waste simple? Why to waste power on that? And this is a very effective technique, by the way, because you're turning off whole blocks of design at one go. You're turning off large blocks of design which have lot of gates, lot of activities. All things will be stopped with that one switch. But there are some cases where you can't do that, right? Which are those? Those are storage elements. So if you have flip flops, if you have some latches, you cannot power down that, right? I mean, we cannot power gate that, right? Because they will need some voltage for to keep it up at that level, right? So what we do, we have a solution that we use a power down mode. We reduce some voltage level, but we keep it at that. So suppose you're using some 1.2 volts, we'll keep it at zero point 0.8 or zero point 0.5, right? Just so that this will be functional. And the moment we need this, we'll again bump it to 1.2 volts or something, right? So these are the leakage power reduction techniques. And now I think we'll move to some dynamic or a very general, techniques which are very much used in our industry. So first one is clock gating. So clock gating is, you know, simply just turn off the clock. We are not power gating it, we are clock gating it. Means we don't want clock signals. And any sequential circuit runs on clocks, right? So every flip flop, every design you are having will turn on and off and will have activities only when it is having a clock. You're turning off the clock, you're turning off the whole design, right? So, so right, but the problem here is you need to have additional hardware. See, we cannot. There is no free lunch, right? We cannot, you know, keep producing power and we not pay for that. We'll pay for it in terms of area. We'll pay for it, right? So additional circuit will be required, which will take additional area, and area is very important design metric. So we cannot lose on area. So it's always a trade-off. Anywhere, anything you do here is always a, you know, a very important decision you make. Suppose how much power you are, how much power you are saving, and how much area you are giving in spite of that, right? So that is a very critical decision you need to make. Um, right. And one more question, by the way, here, that what is the difference between power gating and clock gating? What is the difference in terms of power? I have explained both. So anyone wants to answer this, please think on this. That what exactly is the difference between these two things, and what extra are we burning in terms of clock gating? Right? Keep thinking, and if you have any answers, you can just stop me and. Okay, so next. Uh, Next technique is supply voltage scaling. So we'll simply scale the supply voltage, which the VDD voltage that we have, and that will save us some power, right? But the point is, again, you see, if you reduce the voltage, you have circuit delay will start increasing because it will be slower, right? So everywhere you need to be very efficient in terms of thinking and taking a decision, that why should we reduce and how much should we reduce. We can't just go indefinitely. And second thing is that you need to adjust the voltage and frequency just to match the performance requirements, right? So if some clock has to run at 1 gig, it has to run at 1 gig, right? You can't just keep reducing voltage. It will not run. It will fail. So that's another thing. And for this, sometimes we deploy voltage guidance. So we have a two multi VDD kind of a concept. We use a higher VDD for some blocks. We use a lower VDD for some blocks, and sometimes we use a high performance mode and low performance mode. So some kind of that. But again, an issue is there that we need level shifters, right? From going one voltage domain to other voltage domain, we required voltage to shift the voltage levels. So that's one drawback here. Now we'll see some very top level approaches here. As I had explained in the flow, the first or the very very top level approach, when you are just thinking on it, as the system specifications have come, we are just about to think on the circuits and all. At that level, you need to think. From that level, also you need to think why and how this power can be controlled, can be reduced as less as possible. So the first simple approach is that use state encoding, right? So we need to minimize the number of number of switching activities by using gray codes, right? So that gray codes will have only one change, right? So any number of, any switches, any change will have only one toggle, as you see in the picture, right? So any change the state will have only one toggle. But in binary cases, you see, if you go from 1 to 2 and 2 to 1, you have two toggles, we have three toggles, we have 2 and 3. So we have a lot of toggles. So this work, which can be done by the gray codes, why to waste power on these unnecessary toggles? And if you compute this will come at 1.75, which means 75% more power we are burning in binary approach, right? So anything you do, I mean, uh, in binary numbers, will always have 75% more burning of power, right? And next we'll see the clock gating in FSMs as well. So clock gating we have seen, but in FSMs as well, we can see that clock gating can be very very efficient. So it's very simple. Whenever you have a self loop in FSMs, you simply turn off the clock, because state is 0. If you give an input as 1, it will state in uh, as 0. So why to waste power on that, right? There is no state changes, just keep it there. So we'll turn off clock. Okay, so next we'll see some. This is again a very important topic. This is again used at a very very top level approach. At the very top of the VLSI design flow, this is used. So at the RTL level, when you're writing Verilog codes for a multiplier or for anything, you need to use. There are some techniques. So first one is parallelism. So parallelism says that instead of using a high frequency for one multiplier, we can use two parallel multipliers. So instead of having f, you see, for this multiplier, we use two such kinds of that, and we use one mux and we club them so that that output is the same, right? So again, here you see additional hardware. So everywhere you will see that everywhere we'll use some designing techniques, some design to control, to minimize power. We'll have extra hardware needed. So you need to be very careful on this. We cannot, because why? Because area is cost. The more area you want, the more cost, the more money you pay, right? And nobody wants to pay money. So you need to be very careful when you do this. Second technique is pipelining, which is you all must have heard this. So pipelining is pretty simple. It just breaks down a job in four shorter jobs. So job A, or which used to take 4 clock cycles, will now take only 1 clock cycle for job J1, J1 of job A, right? So the benefit here comes is that this has a less clock, right? Less shorter amount of time to compute. Shorter amount of time means you can reduce the voltage level to compute it. So the job A whole, which was running at 4x times of the voltage, it will only have a x voltage for J1. So the voltage is getting good, it's getting down, and that will save us a good amount of power. And you see there are a lot of jobs, so a lot of stages are there, so we can save a handsome amount of power with this technique as well. So next we'll see at the gate level as well. So these are at the gate level. You see, we have seen at the top level, we've seen at the mid level as well. Gate level is a very at the very low level in the VLSI design flow, and these techniques are generally part of CAD tools, the tools which you use for for the circuits. So these are part of CAD tools, but I will explain a few of them, and so that you get an idea and how do the CAD tools work, right? So first is technology mapping, which is basically reducing the activity by restructuring the design. Suppose this design is there. This is actually a chain structure, and this is a different structure on that. So both of the outputs are same, but we can restructure it and we can have a less power dissipation, right? And second one is phase assignment. uh, we have a high activity node here. We have a high activity input A. So what we do, we restructure all of it and we come up with some other design which is having less nodes with high activity. So you see you have two nodes with high activity because A is a high activity. This will obviously have a high activity. And but if you see in this picture, it has only one node with a high activity. So that's another kind of technique that we use at gate levels. Okay, so I think that's all for power, and I think that's a few. Now the next few slides, I will try and introduce you to the skills that are required as a VLSI engineer, and the things that you must focus on if you want to go in this field. And not only power, right, in STA, and a lot of things are there, and a lot of works are there that are done. So on an overall basis, if you see what all do we need to study for these kinds of jobs, these are the things, right? So first is CMOS theory. You must understand structure working and everything. You must have a very good command on that. This is the very basic things. And then you have the digital logic design. It's a subject as well in the course of PC. And you need to have a good idea on FSMs, right? Because FSMs are generally very good topics for interviews, because these are basic things. They'll ask these, but then they'll go to these FSMs. They'll ask you, design some FSM from this for this circuit or something. They'll ask. And second, and also the third thing is that the FPGA design methodologies and flow, you must be very quick with that. You can't just think on that. It should be very smooth in your head that what flow we use for FPGA, what flow we use for ASICs, front-end design, back-end design, and a part of STL language, because I mean, not required everywhere, but you should know. It's a good skill to have. For scripting, Perl, Tickle, or Python as well. Little bit of Perl, Tickle, and Python would help in scripting. Timing concepts, very much, very important for interviews. Timing concepts in sequential circuits, STA, hold time issues, setup time violations, clock issues, skew, anything. There's a lot of things here. You need to be very much aware of that. Also, some PPA trade-offs, market requirements, some cost optimization. Not much important, but you must. You should know. Communication and time. These are everyone should know. It's not a big issue. And some companies I like to highlight here as part of slide. So product companies are there. They designs and develops ASICs, SoCs, processors, everything. And some are Qualcomm, Intel, Nvidia, AMD, good companies. Service companies are also there, so they work as an outsourced works, and these are Wipro, TCS, and all. Next are some EDA companies as well. So the CAD tools that we use are built by these EDA companies, and Synopsys and Cadence are two widely used uh, tool vendors out there. IP design companies also are, we sometimes use to design some part of our blocks to some with some other you know IP design companies, which are ARMS and Synopsys Cadence as well. Fabrication companies, if you see, we have TSMC, Global Foundries, and Samsung. They also, we have some openings. We can try and see that as well. That's all from my side. I think I went a bit quick, I suppose, but yeah. Any questions you have, any doubts you have, anything you have, you can just ask me.
Thank you, sir, for giving us such a wonderful presentation. So let us start with the question and answer session.
Yeah.
So if anyone who's having any questions which is related to the presentation, college, placements, or any other, may turn on the mic, or else you can also drop your questions in the chat box as well.
Good morning, sir. I have a question that regarding preparation for those companies with VLSI design,
Yeah.
is there any little similarity or very much difference?
Sorry, what did you mention? Little similarity on what? I just missed.
Regarding preparation for those companies with
Yeah.
VLSI design, what
Yeah.
is the difference? It's having little similarity or very vast difference?
No, no. I mean, I told the topics, right? So VLSI design itself is has a lot of openings, a lot of things that we do. Like okay, let me go here. So this design flow, right? This design flow is not a straightforward thing, right? You can work in architectural design, you can work in functional design, you can work in circuit design, and all those topics that I've shown you are all the topics that comprise of all the things that we need to know. Suppose you went for a placement, you won't be asked you won't be asked specifically to some on specifically on PD, specifically on functional design. That happens only when you go for specific inputs, and that only happens if you go for company switches. If you want to switch to a company, then they'll be very keen on you want only for this or that. But if you, as a fresher, if you want to join, you need to know basics of all of these things. Like you need to know circuit design, you need to know functional design, you need to know timing issues, timing concepts. Physical design, you can skip. PD you can skip. But if you are going for a PD field, they will ask partitioning, they will ask some series and all, placement and all, how to do full planning, how to divide things, how to do placement, right? So the things that I mentioned there comprise of all the things. I hope I've answered your question. Anything else you want?
Yes, sir. No, sir. Thank you.
Okay.
Hello, good morning, sir. I want to know that does VLSI related job is something related to chips designing?
No, you need to understand VLSI. Okay, let me give you. I think I have that presentation as well. I gave for Matthew sir. So the job profiles you need to know. It is not a simple one job profile, right? First, you have a engineers, right? Where you have a lot of things. Where you have front end designers, back end designers. Front end will also have. You can work in DV, you can work in RTL, right? A lot of teams are there. You can work in back end as well, physical design as well. You can and by the way, back end is not only for PD. PD is the main part of back end, but other things are also there. DFT engine is there. Custom designing is also there. So lot of things, lot of jobs are there in self in design engineering. Then verification engineers, validation engineers, modeling engineers, right? And you have CAD engineers that I mentioned, right? The CAD tools that we make, EDA tools that we make. Also after that, some application engineers are there, which work as a pre-sales or a post-sales interface between the R&D department and the OEMs. Sales jobs is also there. So a lot of jobs are there. You cannot just say VLSI design job, right? So you need to be specific in terms of what job you want to know, right? Anything else?
Okay, thank you, sir.
Okay, I think this topic is point is clear, right? So there are a lot of departments in VLSI flow.
Yes, sir.
Okay.
Good morning, sir. So my question is that is it important to go for higher studies to make a good career in VLSI?
No, it's not important, but I mean, it's not a sort of must thing. But in BTech, if you get a chance, it's very good. But generally, BTech does not have a dedicated course for VLSI. And I think in my course was one elective was there, and that also we don't study electives. We know that, right? We only study the main subjects, and we just skip on the electives. And so we don't have a very good understanding of VLSI in BTech. I mean, if you want to do it, you can be aware, but I was not aware of that. So it's better to go for a higher studies and take VLSI as the course and understand all the digital circuits, analog circuits, the whole flow. There will be a lot of courses will be there. Take all the courses, understand it, and then try for a VLSI company. I mean, you can try anyway, but it will be very better equipped if you are have a master's degree in VLSI.
Thank you, sir.
Good morning, sir.
Yeah.
Is jobs in VLSI are having good work security than CS oriented jobs, are they are similar?
No, no, it's not like that. You can actually, you can't compare like that. I mean, any field will have some companies which are job secure, some companies are not. It's a very, gray area if you ask me. It's not a very straightforward answer you can have on this question. But yeah, VLSI industry will also have, good, you know, good jobs, very stable jobs, right? CS will also have. I don't have much experience on that, but CS also has this kind of job. So you cannot just discriminate. I mean, you cannot just not discriminate. You cannot just divide in terms of right stability in terms of CS and VLSI, but it's there in VLSI as well.
Yeah, thank you, sir.
Any more questions?
Um, so I just want to ask, like, being in the like working so long with the
Yeah,
Qualcomm, can you suggest us some resources for the students, like the students that have joined from first year and the second year? We all
yeah,
have
yeah.
numerous resources present on the internet, but a perfect roadmap to prepare for something always helps by the alumni. So, can you guide us?
Yeah, sure. I mean, I mentioned that here the topics and the resources. I'll let me see if I have it here. Yeah, I think some NPTEL courses should do CMOS design and hardware modeling. We'll assign physical design as well. This has a lot of low power techniques explained. Right. I think in the lecture 12th, if I'm not wrong, so 12th, 13th, and 14th, I think those 5 or 6 lectures that we see that has a lot of good techniques, which I've explained, some of which I've explained here, and also some you can try some other platforms, for courses. Books, I will say, this is a very good book, Design Perspective by Rabe. Analog if you want to study, you can study this book. VLSI design, yeah, Neil H. and D. Harris. That's also a very good book to understand CMOS. And if you want to, have some understanding on, some, simple concepts in a very good, detailed way, this site is also a very good site for VLSI students, for some small concepts and all. I mean, it's not easy, right? If you see, it's a lot of things, but yeah, if you study in a very dedicated manner, I think it's going to be good for you.
Thank you, sir. So one more thing, I would like to ask that what are your suggestions that you want to give to the freshers students, like for preparing their CVs, how to make it so that they can crack the interviews of, they can qualify for at least the first round of the companies.
No, no, no. Yeah, I mean, it's not like that. I mean, yeah. Suggestions. I mean, uh, you need to know what the company wants to ask, right? So, if you are, hello, am I audible?
Yes, sir, you're audible.
Yeah, sure. So, if you're going, I mean, your CV must reflect what company is asking, right? I mean, it's a very simple answer to this is that if you're going for a PD profile, you will not give a front end answer, right? You will not design a CV for some DB, right? Some verification techniques. So it's very simple. If you are applying for the job, you must know what job, what person are they looking for. So if they are looking for a verification, you should be very swift, very equipped with verification techniques, and you should very equipped with the flow, and you should mention that in your CV, right? because right, and you should have a larger amount of CV shown in terms of that. If you're going for a PD profile, show them that you have done some courses on PD. Show them that you have done some experiments on that, or you have done some designs of that. You've studied some online codes with respect to that. So that's the only thing I'll suggest here. I think I have a slide for CV building also, but yeah, it's the same. It's the same thing. It has like uh, these skills are pretty. I mean, low power design. It's a very demanding topic nowadays because everyone wants to have low power. Nobody wants to burn unnecessary power, and this is one of the major design metrics that have come up actually, because initially we only had timing and area, right, and frequency, the clock, as design metrics. But nowadays, I mean, they are very keen to understand power as well. They're very keen to reduce power from the very start. So yeah, I mean, these are the things. I mean, in a nutshell, if you want to say, as the CV should reflect exactly what they want. So by that means, I mean, they will not reject it. I mean, they should not reject it at the first go. So that's the only thing. And also, pointer helps. Pointers always help. So if you are in first year or second year, you must have a good pointer. Just try building good pointers, because I mean, pointer. There are some short listing based on pointers as well, I've seen. So you need to have a good pointer.
Thank
By
you,
the way,
sir.
any more questions? But I'll just answer this what I had asked. So leakage, I'll tell you why it's very much important. Where is that? Yeah, leakage is 5%, but leakage is highly dependent on temperature. So if you increase your temperature, right, the leakage will increase exponentially. So that 5% might not look a very large number to you now, but suppose you go in some parts of Rajasthan and you are using your phone in some 50 degrees Celsius, right? Then you will see that the power comes in pretty high. So we don't want to have a design which is only for room temperatures, right? So that is why leakage is also a very good, very important point, a very important parameter to have a control on. And the second one which you asked was the difference between power gating and clock gating. So you see, power gating will shut off everything, right? Clock gating will not shut off everything. Clock gating will shut off the circuitry, but the clock tree structure will not be off, right? So clock gating will have the clock tree structure running, because we need those flops to clock gate the actual design, right? So the so there is a difference between these two. Clock gating is very good. Power gating is also very good, but we need to know where we want to use both of them at different conditions. And and be careful, because I mean, clock gating. If you do clock gating, the clock structure, the clock tree structure will be consuming power, will be consuming dynamic power, will be consuming leakage, right? So that's the difference. Yeah. Now, if you have any more questions, you can take.
So I think there are some interesting questions in the chat box dropped by students of first year branch EC. So Harsh Kumar asks that how thousands of transistors are combined in a single small chip.
Yeah, that is VLSI, by the way. So if you want an answer, you have to study VLSI. So that is VLSI. That is how VLSI has emerged, right? So we had small scale integration first, SSI, then we had medium scale, then we had large scale, then now we are having VLSI. So you must study circuit sizing and all. I mean, it's a very vast topic. You can explain it in a few words. But that's in very short. If you want to, if I want to answer this, the at the very device level, the channel length keeps on decreasing and decreasing. I mean, the industry has worked on the channel length, and from 200 nanometers to 65 nanometers to 28 nanometers, 14, 7 nanometers, and now I think around even 2 angstroms, right? 20 angstroms, sorry. So even 20 angstroms is possible. I mean, that's a next node. So the channel length or the tech node that we are going for, it's kept on decreasing through the years, and now we can pack millions of transistors in a single chip.
Thank you so much sir, for answering this question. So next question is from Lakhara Aditya Shri Gopal. He asked that which is better to pursue MS in VLSI or Mtech in VLSI?
See, MS is for research. MS is for research basically, and Mtech is for is a course. I mean, Mtech is not a research specific research. MS, if you enter, it's from the first day itself, you will be given a topic, right? You will work on research. We'll have very few courses in MS. So most parts you will only be working on your research. Mtech, it's a course structure, right? It's like a BTech, it's an Mtech. So we'll have some courses, and in the end, you have a thesis, Mtech thesis, which is only for one semester, probably one semester. Two semesters are there, but only one we work. One semester just goes by understanding things, right? So you will have a lot of courses in Mtech, less courses in MS. So you should know whether you want to pursue research or you want to pursue. I mean, you want to have a balance between courses and the thesis, right? So if you're very much interested in research, you want to have a PhD. After that, you want to go in teaching careers. You want to go in some teaching jobs and all. Then it's a very good. I mean, you can also go for a job after MS. It's not a I mean, it's not a very thumb rule, but but MS generally means research. That's the only difference between these two courses.
Thank you, sir. So now there's another question from another student of first year branch ECE. Harsh Srivastav asked that if we are a computer enthusiast and want to explore different aspects of computers in detail, but
Yeah.
also want to do masters in a core branch, so
Yeah.
can you suggest how to manage preparations for GATE in electronics along with computers?
That's a very good question. It's a very wide area because you're asking on computers. Computers have a lot of things, right? Computers have memories, computer have softwares, computer hardwares. In hardware, you have CPUs. A lot of things are there. So, I mean, you must select one thing out of that. You cannot go on understanding every aspect of that. You must be having a basic idea on all of the topics there that I mentioned here. But if you want to, research, if you want to have a specific degree, you must select, right? So, so this VLSI circuits comes under hardware. So if you are interested in, designing chips, if you are interested in, understanding how the hardware part of the computer works, or specifically the how a lot of, as he mentioned, right, a lot of transistors are put in single chip, how that is done, that is hardware. But if you're interested in software, then it will have a completely different field, right? The CS field will be completely different from this. So you need to know yourself first that what do you want to do. I know you cannot just go haywire and just start studying everything that's involved computers. That would be a very ambitious task. Yeah, that's what I need to say. And what's the second part you asked about gate, about some gate, right? Gate exam and all.
Yes, sir.
Okay, so gate, yeah, I mean, part of the syllabus comes in gate. I mean, gate will focus on all the communication, electronics, both parts, right? In gate exams. I mean, VLSI will focus only on the logic part, on the timing pass. Will not focus on the communication side. But eventually, like I'm working in Qualcomm, right? So Qualcomm makes devices, but it works on the communication as well. You're making for communication. You're making to communicate faster wireless devices. So you need to have an idea of communication as well. So as a student, I mean, as a student, I mean, I think that any student should study, you know, basics of communication and electronics as both of them, and then they should, focus on the specific areas that they want to master. The basics are always, mm, the basics are always needed in any part of industry, right? If you go for an interview as well, they can ask you a communication question. I mean, they will not ask only the electronics, right? So if they need some basics of communication, they'll ask, right? So I think that you should have a basic idea of all of the subjects that you study there, and I mean, and specifically, and I mean, you can master in one or two, but you must have a basic idea on all of it.
Thank you so much, sir. So now I think due to time constraints, we won't be able to take any more questions.
Yeah.
However, if the students have any, then they can mail queries to Team Anuvrat, or you
Yeah.
can also directly connect to the speaker, Mr. Animesh sir, via LinkedIn. So
Yeah.
now
You can
I
also
would
use my mail ID as well if you have any questions. I mean, I'm not quick in answering I'm checking mails and all, but yeah, I'll try and uh, answer as fast as I can.
now I would like to welcome Mr. Ankur, uh, who was a part of Vimrishyotsava last year. Last year, in the previous season, in the last episode, he guided us on the topic of radar system. So I would like to welcome him and kindly provide any suggestions and share his knowledge with us.
Yeah, hi everyone. It was a wonderful talk by Animesh. Hi Animesh.
Hi,
It was a
hi.
wonderful talk. Yeah, and I think all the BTech EC students must have benefited a lot from this. Moreover, I think uh, the students who have genuine interest in VLSI should definitely pursue it as a career option. I think Animesh would also agree to this because instead of going into other fields, you should either go for higher studies in VLSI or you can also go in some good companies, which Animesh has already explained. So yeah, it was a very good talk and nice to be listening to this talk. Yeah.
Yeah, yeah. Thanks. Thanks, Ankur. Yeah, yeah. What Ankur said is pretty correct. That these industry is really, really good. You have a lot of options here, a lot of career options.
Thank you so much, Ankur sir, for joining with us. So now I would like to welcome the faculty in charge of our club, Anuvrat, Dr. Hemant Kumar Kathania sir, to share a few words, ideas, or any suggestions.
Hello.
Hemant, yes, sir.
Hi. Hello, Animesh. How are you?
Hello, sir. Fine, fine. Yeah, it's a
Yeah.
really long time. We are meeting again.
Meeting
Yeah,
again. So how things going on?
Yeah, it's good, sir, and it's really
So
nice that this our Anuvrat society has come up
uh,
with this.
yeah, your juniors are doing the things.
We should have done. Yeah,
So right now you are in Bangalore or Pune?
Bangalore, sir, Bangalore, Bangalore.
Bangalore, Bangalore. And where is Ankur? Ankur, hello Ankur.
Good afternoon, sir.
Good afternoon.
Hello, sir. How are you?
I'm good. How are you?
Yeah, I'm good. I'm good, sir.
So
Nice to talk to you after so long, sir.
so right now where are you?
Sir, I'm in Bagdogra, West Bengal.
Bagdora means Bagdora airport or some like other?
Yes, sir. Air Force Station. Air Force Station.
Oh, Air Force Station.
Yeah.
Okay,
Actually,
that's
Bell has installed some radars over there. So inside the Air Force campus for
okay.
the Indian Air Force. So I'm in charge of that radars. So
Oh, that's great. Good. So
yes.
if you guys have some time, then come to campus also.
Yeah, sure, sir.
Yeah, sure. We are planning actually since very long, but it is not
Yeah.
formulating right now. Yeah.
But I think for Ankur maybe easy because his home is also nearby.
Yeah, yeah,
Yes,
For
yes.
for Animesh maybe a little difficult.
correct, sir. Yeah, it's time constraints are always there in
Yeah.
private jobs. So
Mm,
yeah, we'll see
yeah.
if time permits.
Yeah. Whenever you have time, like we plan 3 4 people and come to campus and
Yeah, sure, sir. We'll sure have fun. I mean, it's been a long time. It's always good to come back to the college and
yeah. Uh,
finish.
Yeah, it's good, a nice talk. At least now, juniors get some benefit, like how they can prepare for VLSI engineer, right? How they can go for higher things, like maybe masters or MS or something,
Yes.
right? So they get some benefits. And now, if you have some time, then you can tell them like how they can prepare for the gate thing also, because this gate is little different thing than these companies,
Yeah, correct, sir. Correct, sir.
right?
Yeah, yeah, correct, sir.
So if you have some time, then you can speak with your third year or final year students. So you can guide them like how they can prepare for the gate things, because now gate has changed the patterns and everything, right?
Yeah, sure, sure, sir.
So if you can talk them, they can think like how they can score well, because getting IIT is that to IIT Delhi, IIT Kanpur or something. You require a good gate score.
Yeah, yeah, yeah,
Without that is not possible. Yeah.
yeah, yeah, yes.
Yeah,
Yeah, I
so
mean, I mean, you all have my ID, right? My email ID, so you can just mail me, and yeah, we can sync up offline.
yeah, sometime maybe you can just give us some kind of suggestions like how you can prepare. Maybe you, Anku, or some other student who prepare for the gate or something.
Yeah, sure, sir. I mean, it's really good to
Yes, sir. Even
really,
even Anurag is there, so he can also give some
Yeah,
yeah,
insights because
yes,
correct.
he has
yes,
also good experience.
yes. We can call Anurag also. Yeah, so
Yeah,
Yes, sir.
the three four people you can just have a meeting with your third year or final year student and give them some kind of suggestions like which subject need to prepare hard or which subject is
mm,
little bit easy, which subject need to focus more or something like that. Okay, so that kind of things will be more useful for them. Those who are willing to prepare for the gate. So
Yes.
other things are okay, and
yeah,
yeah, so good. So thank you for joining. And one more thing, guys. Since you are now alumni, you can give some kind of suggestion to the Anuvat, like how they
yeah,
can improve, how they can organize a different kind of events.
yeah,
Right.
yeah.
So whenever you have time, just
Yeah,
write a mail
I
to
think,
the
sir, this is a very good initiative. I mean, this is I mean, because alumni has to help the students, right? So
right,
this is a
right,
very good initiative for the alumni as well. And I mean, as the students, of course, right? They need to come up and we can discuss and we can share our experiences and knowledge. So
right.
this is
Because
a very nice
uh,
initiative, sir.
I think they will listen you because टीचर के तो सुनना है नहीं ना टीचर
No, no.
टीचर का तो
No.
4 साल के बाद पता चलेगा कि क्यों बोल रहे हैं क्या क्या जरूरी है right
No.
so at least they can learn from alumni so
Yeah.
that things
Yeah, it
yeah
happens. It happens, sir. We
yeah
also were like that as well. Yeah.
this is the part Like,
This is a part of the BTech.
yeah, part of BTech. BTech means like full masti, but with some
Yeah.
kind of like good preparation. Because if you less the pointer now, because tell them
Yeah,
because
that's a very good
main
point, sir, that you have mentioned. Actually, I also wanted to discuss because pointers are really a very important metric because
yes,
I was one of the students which do not wanted, I mean, which was good, but I had a feeling that okay, pointers will manage. But after going to IIT Delhi and seeing the condition and seeing the spaces there, I knew that pointers will affect you. If you have
yes,
a bad pointer, it will affect you somewhere or the other in the timeline. So
right,
that's
right. Yeah, because now they can understand because if they're third year, fourth year student, those who are second division in 10th or 12th class, so now they cannot
yeah,
able
correct.
to
Same
go
issue,
to
sir.
the many
Correct,
companies,
correct.
right? And the
That's
same thing in
sometimes
marks,
it's a cutoff, sir. Sometimes
right?
the cutoff 8 pointer, the cutoff 8.5 pointers.
Yes, yes,
Even
yes.
you can't even sit.
Mm-hmm.
So that's a problem.
Yeah, that I think they should maintain their marks, otherwise difficult.
Yeah.
Yeah, and then this 2 year this online courses are I don't know how they are
Yeah, that's
now
again.
they are.
I'm also very surprised, sir, how they were managing online courses and
But
because
now things are offline. Yeah,
okay,
but
yeah, nice to know.
now from last one semester things are offline. So now they are seeing the changes because it's online and offline both are different things.
Yeah, completely different, sir. Agreed. Totally
Different
agree
things
on this
because
topic.
yeah, because they should enjoy the campus life. They should go
Yeah,
to the laboratory. They should talk to the friends or something. In offline, always home, home, home. What they will do.
correct, correct. Right.
So that the things. Yes, good to have you for this talk, and thank you for your time. So maybe in future also we will call you for some gate thing or something, right?
Yeah, sure, sir.
Yeah,
Let's see
yeah.
if we can.
Okay, okay, Animesh. Then thank you from
Okay.
my side.
Thanks, Hemant, sir. Thanks a lot.
Thank you so much, Hemant sir, for your words. Your presence and guidance and support has always motivated us to keep going. Thank you, Animesh sir, for spending your time on our development. We have learned a lot from you, and thanks to the audience for joining with us today with such an active participation. We all are once again delighted to have you today. So, we are wrapping up now with the promise to come back with another exciting episode with some more brilliant minds. Thank you once again. Have a good day, everyone.